Okay, so let's do 2. Let's do 5 and 6. These are pretty easy, pretty straightforward. So review question number 5 is talking about how to approximate the mean and the median, right? And so remember that the median is the middle, 50% of the data. And so if you think about this as, an area of a shape, half of it, estimated to be somewhere probably right around there, right? And again, 50% is here and 50% is here, okay? And it's just an approximation. The mean, because we know that this thing is skewed right, this tail is going to pull the mean a little bit, maybe not a lot, but we'll just mark that as the mean. And that would be enough for me for understanding credit. Or if it was a multiple choice question, you would clearly pick the one where the mean is to the right of the median because of the overall skewness of the distribution. Okay, so then we jump into really the heart of section 2.2. And this 68, 95, 99, 7 rule, this happens when you use the word normal, not standard normal, right? Standard normal is z-scores. So this is just a rule for any set of data that's normally distributed. So it's talking about horse pregnancies. Bigger animals tend to carry their young longer. The length of horse pregnancies from conception to birth varies according to a roughly normal, so now we know it's normal, distribution with a mean, an average of 336 days and a standard deviation of 3 days. Use this to answer the following question. So let's use the mean and the standard deviation of 336 and 3. I'll come over here and we're doing number 6. And so because they told me that this data is normally distributed, I mean single peaked, symmetric, with the mean value right in the middle, 336, and a standard deviation of 3. Well, given that it's normal, we know that one standard deviation would be 3, so 339. 2 would be 342, and 345. Going this way, 333, 330, and 327. Okay, and we also know, because it's normal, that the 68, 95, 99.7% rule applies. And again, what is that? Well, if you're just catching up on this chapter, that means that one standard deviation away in both directions will capture 68% of all of the length of horse pregnancies. If you go out 2, right, you know that 95% of all horses have a pregnancy that lasts between 330 days and 342 days. And if you go out 3 standard deviations, both directions, you capture almost 100% of the data. And so it'd be very odd and rare, right? 0.3% of the time, you'll get a pregnancy that lasts longer than 345 days or shorter than 327. Okay. And so question A says almost all, 99.7% of horse pregnancies fall in what range of lengths? So 99.7% of all horse pregnancies falls between 3 standard deviations away. So it's this guy and this guy, 327 and 345 days. Okay, simple stuff. Part B wants to know what percent of horses are longer than 339. Okay, so 339 days. There's the question. Well, the way that this chapter started is we gave you numbers that landed right on those particular values that satisfy this condition, right? We don't have to change this to a z-score, even though you guys know how to do that because this is a review, because it lands right here. And so what we're doing is we're looking for what percent is above 339 days. Well, let's just do some simple math. We know that this is dead center, and so this is 50% that way. We also know that 68% of the data falls between here and here. Well, because of symmetry, that means that this side is half of 68, so that's 34. And so if you take 50 and 34, that's 84%. And so this must be the other side, right? And if you capture 100% of your data, you would say, well, what's 100% minus 84% to get your answer which is 16% of all pregnancies, take longer than 339 days. Okay. All right, guys. I'm not sure if I think that was the rest of review 1. If so, I'll go post these now.